Our lifestyle, primarily driven by burning up fossil fuels, is accelerating climate change. Significant steps are taken in alternative energy sources, but not enough in the areas that will see a massive increase in energy consumption in the next decades: Asia and Africa. Here's the situation. Ever since carbon energy was discovered, its use has seen steady growth, decade after decade, and this trend continues. But this growth is not evenly divided across the globe. For the last 100 years, most of the energy production was built in the OECD countries. But around the year 2000, something happened. OECD countries suddenly stopped adding new energy production capacity, and at the same time the build-out of new energy production in other parts of the world increased rapidly. In the next 3 to 5 decades, we will see a massive increase in the global energy markets that beats anything we've seen in the past. And Asia and Africa are the main drivers for this growth. That led us to take a look at what could potentially supply all of this new energy. In order to get a better view, let's take a look at energy sources over the last 30 years. We start in 1990 when fossil fuel provided 80% of the global energy mix and wind and solar provided less than 1%. Now, we will step forward 5 years at a time until today. As you can see, it only changed a few percentage points along the line, and still today fossil fuel provides 80% of the global energy mix. Because even though wind and solar has grown, its growth has not been much faster than the growth of the entire energy market. Thus, wind and solar has had a hard time to keep up with increasing energy demand for the last 30 years. Now, the big question is, what will this pie look like 10 years from now? We believe the pie will eventually have to include thorium molten salt energy. Thorium is a metal in the periodic table, and we get it out of the ground by mining, just as we mine for copper and iron. There is enough thorium to provide all of the energy for humanity for thousands of years, and if mined on an industrial scale, it costs less than $100 for the energy you consume in your entire lifetime. Thorium is abundantly available in all countries of the world, and the difficult part is not the mining. It is converting thorium into energy efficiently. In order to convert thorium to energy, we need a machine called a molten salt reactor. This was first shown to work in the 1960s, but it is not until today that we have the sufficient knowledge and production techniques needed to commercialize it. At this very moment, Copenhagen Atomics is collaborating with the industry to accelerate the breakthrough of this technology by developing products, bringing them to market, and sharing the knowledge gained. At Copenhagen Atomics, we are working on something that can be mass manufactured on an assembly line, the first commercially available molten salt reactor. We are expanding and on the lookout for talent and industry collaboration. See more on www.copenhagenatomics.com or send us an email on info@copenhagenatomics.com.